Hello students, today is April 22, 2023 and we will be solving IB Math AA SL May 2022 paper 2 time zone 2 section A questions and we will be solving the section B questions of the same paper tomorrow, that is Sunday, April 23, 2023 from 5 p.m. IST. Okay. And as I have said before in our last session also, and maybe you are being able to see what I have written on this side, the left-hand side. That is, I have requested you all, if any one of you is interested in knowing how to solve the IB Math AA SL November 2022 past paper questions, that is paper 1 and paper 2 questions, please do send to me the PDF formats of those question papers so that I can solve them, I can explain the solutions to them in our live sessions in our coming weekends. But I do not have the PDF formats of the question papers. So please do send to me the PDF formats of the question papers by my email. You can just email me, okay? So, and the email ID is also given in over here. You can see my email ID. You can send through WhatsApp also. The WhatsApp number is also given below. So if any one of you is interested, please do send to me the PDF format of the two questions. Okay. So without any further delay, let us start with that today's session. Today we will be solving section A questions of paper 2. So we will be allowed to use the calculator, and section A questions means question 1 to 6 will be solved today. Okay. Question 1, maximum mark 6. The following diagram shows a circle with center O and radius 5 meters. So it is, I hope you are being able to see the entire diagram. So it is 5 meters. This is 5 and this is also 5 meters. Points A and B lie on the circle. These are the points A and B, and angle AOB is 1.9 radians. So they are asking the first subpart of question 1, that is subpart A of question 1, is asking us to find the length of the chord AB. Let us just move back to the diagram. This is the chord AB, the straight line. Okay. So you can find the length of the chord AB by using the cosine rule. This is one of the ways. It contains only 3 marks. So let us try using cosine rule. You see, length of AB has to be found out. So the angle opposite to the side AB is this angle AOB, which is of 1.9 radians, and the radius of the circle is 5 meters. So we will be writing AB square will be equal to OA square plus OB square. The center is O. Let's check once more. Yes. OA square plus OB square minus times OA times OB cos angle AOB. This will be 5 square. OA, it is the radius, so it is 5 square. OB is also another radius, so 5 square minus times 5 times 5 times cos 1.9, because angle AOB is 1.9 radians. Okay? AOB is 1.9 radians. Okay? This is the cosine rule formula, and this will be equal to 25. 5 square is 25 plus 25 is 50. 5 times 5 is 25 times 2 is again 50 times cos 1.9, or okay, since I have written this separately, first of all, let me get the value of cos 1.9. Negative 0.32329. Negative 32329. Negative 0.32329. What is this equal to? Let us find out. Will be 50 minus 50. So 50 minus 50 times by that value is equal to 66.1645. This is AB square. Okay. What is AB equal to? Is equal to square root of the answer. 8.13416. So up to 3 significant figures, we can take the answer to be equal to 8.13. The length of the chord AB. This is one method. I can write this as method 1. What is the method 2? Let us draw a triangle. Draw a triangle. I'm drawing an isosceles triangle, of course not scale. And this is 1.9. This is A, this is B, and this is O. See, I have drawn this triangle AOB. This one. Okay? And since the radius of the circle is 5 meters, this is 5. and this is also 5 meters. Okay. So now it is an isosceles triangle. Therefore, if I drop a perpendicular from the vertex onto the base, it will be connecting, or it will be touching the midpoint of the base. Okay? M is the midpoint of AB. And this perpendicular will not only be bisecting this base AB, but will also be bisecting the apex angle, the angle EOB. So angle MOB is equal to 1.9 over 2. Okay? Angle AMOB is equal to 1.9 over 2, which is equal to, if I write this as 1.90, then this will be equal to 0.95. Okay? Of course, in radians. Therefore, now I am taking this triangle MOB and I am trying to find the length of MB, because I know MB will be half of AB. If I can find the length of MB, I will be able to find the length of AB just by just doubling it, by multiplying by 2. Okay, so I can write MB over OB, MB over OB. This is opposite to this angle 0.95, and this is hypotenuse. OB is hypotenuse. So opposite over hypotenuse is what ratio? It is sine. So it will be sine 0.95. Therefore, MB is equal to OB. OB is 5. 5 times sine 0.95. Let us find out the value of this. 5 times sine 0.95. Enter. 4.06708. 4.06708. Let us check. It is 4.06708. Okay. So MB, but we need to find the EB. So what is EB? AB will be equal to 2 times 4.06708, which is equal to 2 times answer equal to 8.13. Again, the same answer. Has to be because the code is the same. Okay. So this is the method number. So we are probably done with the subpart A. And now it is the subpart B. Find the area of the shaded sector. Shaded sector. That means this part. Okay. Again, there are 2 ways of finding this. One way is to find this area of this minor sector. This is the major sector because it is having the larger area. That is the major sector. This is the minor sector. You can find this, the area of the minor sector, and then the area of the entire triangle is pi r square minus this. Okay, let me just show you both the ways. The pi p. This is not much. Let me try. So it is not any line because I don't have much. This is method 1. Or let me one line if I have much think of process. Okay. So it is subpart B. And method 1, so method 1 is I'm first of all getting the area of the minor sector. AOB. It will be half theta r square. And what is theta? It is 1.9 and r is 5. Okay. So therefore, area of the major sector AOB will be equal to pi r square, that is the area of the entire circle, minus this. I can write in place of r square, I can write 5 square. So pi times 5 square minus 1.9 over 2. We have just over here given calculated what is 1.9 over 2. It is 0.95. So 0.95 times 5 square. Okay. I think you are being the whatever I am writing. So it will be 25 times pi, 25 times pi minus 0.95 times 25. Enter. 54.8. Equal to 54.8 meters square. Okay. This is the first method. Let us try with the second method. Let us see if we get the same answer. So this will be method number 2. For this, what we'll be doing is we will be finding this angle. See, the first method was just to get the area of the entire circle minus the area of the minor sector. Now we will be getting the area of the major sector directly. For that, we need the sector angle. And we know that the total angle around a point is 360 degree or 2 pi. Because this is in radius, so we have to take 2 pi, not 360 degree. And from 2 pi, we will be subtracting 1.9 to get this sector angle. And once we get this sector angle, we will be applying the same formula, half theta r square. R will be 5 and we will be getting the area of the major sector directly. Okay. So sector angle is equal to 2 pi minus 1.9 equal to whatever it is. Let us not calculate this part, and I can calculate, but in that case, I'll be taking the first 3 or 4 digits and keeping it as it is. Therefore, area of the major sector AOB is equal to half times theta is this pi minus 1.9 times r square. That is pi square. Let us find what is this equal to. Half. Okay, I'm writing 0.5 place of half. You can write half. It's not that. Okay, let me just show you with half. It's not that you will be getting a separate answer if you write 0. Half times pi minus 1 point times pi square. I'm writing 25. Okay. So enter. 54.789. You see, you're having exactly the same value, which is 54.8 up to 3 significant figures. Okay. So now we come to the second question. Maximum mark 5. The derivative of a function g is given by g dash x. The expression is equal to 3x squared plus 5 times e to the power of x, where x is a real number. The graph of g passes through the point 0, 4. Find g of x. Given g dash x, they are asking us to find g of x, so it is a case of integration. Fine, because g dash x, when integrated with respect to x, will be giving us g of x plus c. Can have an expression with some x and there will be a constant. Constant can be equal to 0, constant can be a non-zero now. Okay. We will be integrating. In place of g dash x, we will be writing the expression is 3x squared plus 5 e to the power of x dx. We can separate the terms and the coefficients can be kept outside the integral sign. Plus 5 to the power of x dx. So this is equal to 3 times x cube over 3, because 2 plus 1 is 3, So it is x cube over 3. X to the power of n when integrated is x to the power of n plus 1 over n plus 1. So it is x to the power of 2 plus 1 over 2 plus 1. This is this, and integration of e to the power of x will be giving us e to the power of x. Let's see. This is equal to x cube plus 5e to the power of x plus c. So this is g of x. This whole thing is g of x. This g of x, this part, can contain a constant. It is not that it will be containing only the terms containing x. It can contain some constant. To that expression, if you add or subtract some more constants, the gradient of that function will be the same. That means gradient of that function means g dash x. Okay? So don't have to go to those details because you know this, but what I am saying may be appearing to be totally weird, totally nonsensical. It is not nonsensical, but it may be sounding too very odd, strange, weird, and difficult to comprehend. But don't have to go to those things. We have to solve the question and we have to give the value of g of x. The expression of g of x, fine, we'll be giving that. Okay? Because we have to get the value of c, we will be using this point. 0, 4. So x equal to 0, y equal to 4. Therefore, this is y equal to 4, x equal to 0. So 0 to the power of 3 plus 5 times e to the power of 0 plus c. 0 to the power of 3 is 0. So this is 0. E to the power of 0 is 1. 5 times 1 is 5 plus c. C will be equal to 4 minus 5, which is equal to negative 1. Okay. Therefore, g of x is equal to x to the power of 3 plus 5e to the power of x minus 1. Okay. Doesn't contain any subpart. It has asked us to give g of x. We have given g of x. We have completed question number 2. We come to question number 3. Contains 6 marks. Okay. And is saying Gemma and Kaya started working for different companies on January 1st, 2011. Gemma's starting annual salary was $45,000 and her annual salary increases 2% on January 1st each year after 2011. First subpart says, find Gemma's annual salary for the year 2021, 10 years after, the nearest dollar. Increasing by 2%. Is 45,000 initial salary. Therefore, it is what 45,000 it is type of a compound interest. The initial deposit is 45,000 and you are getting interest every year by 2%. Okay. and it is containing 3 is percent of over 100 and check whether it is 2% and 10 years. So this should be her salary the year 2021. Let us see. And before done everything, calculator will be doing for the plus 45,000 times 1 plus over 100 the power of 10. This is equal to 54854.7. So it is nearest dollar they have said. So it will be 54855. 54855, the nearest dollar. We have completed subpart A, subpart B says, have completed, and subpart B says, Kaya's annual salary is based on a yearly performance review. Her salary for the years 2011, 2013, 2011, 2013, 2018, and 20 shown in the following table. Annual salary in dollars, and subpart B is asking us that Kaya's annual salary can be approximately modeled by the equation S dollars equal to AX plus B, show that Kaya had a higher salary than Gemma in the year 2021. The table is not having to according to the model. So first of all, this is the regression equation. We have to find this regression equation. That means we have to find the values of A and B. Okay. So this is subpart B. And first of all, we have to put the table. This one is X is the year. This one will be the salary. Starts with 2011, probably 2013, 2014. The 24 and 20. Starting is the same, 45,000. 47,200. 48,500. 53,000. 57,000. 'And so we have to find the regression equation. So menu, statistics, stat calculation, linear regression mx plus b. The x list is the year, y list is the salary. Now, you see this is a m. This will be, if I come to this, always read this value. Why I'll be showing you. This is 1096.89. This is also 1096.89. And then you are seeing that 119. So you can safely take 1096.89 as the value of A, because you are having this A over here. In GC, A is equal to 1096.89. 1096.89. Now coming to B, see this one is minus 2.1607. As I'm moving the arrow over here, then you can read something else. But if you just write B value as minus 2.1607, you don't take the cursor to this point, you are just seeing minus B's value as minus 2.1607, it will be totally wrong. So I suggest that you take the cursor to this point, or you activate the cell, and then you see it is not minus 2.1607, rather it is minus 2160753 and 88 or 89 I can take. So it is minus 2160753 is equal to minus 2160753. Hope I have written correctly. Minus 2160753.89 empty. Okay? Because I have taken up to 2 decimal places for the A, I am taking the same for the B. So never read whatever is visible. Okay? Either you take the cursor to that cell, you will be getting the exact value. You can see the exact value visible. Or else you activate the cell, so you get the value of that what is entered in that cell over here. But this is for TI Inspire. There should be some equivalent method for the Casio calculator as well, which I don't. You have to find out. 753 point, because it is 886, so I'm taking 89. Now that we know this is S, so let us write the S thing. S equal to 1096.89 X minus 2160 753.89. So now the question says that so that Kaya had a higher salary than Gemma in the year 2021. Therefore, in the year 2021, and X is the year. Okay, 2011, 2013, all are X values. So in place of X, we will be writing 2021. Therefore, S 2021 is equal to 1096.89 times 2021 minus 16753.89. Okay, let me 1096.8 1096.9 times 1 minus 160,753 160,753.89 equal to 560,60.8. They have asked us to just show that it is higher. They did not say up to the exact or nearest dollar or something. So I can give this value 56060.8. And instead of, if I take in place of 89, if I take 1096.9, if I just ignore this 0.89, you'll be seeing whatever value you're getting for S 2021 will be changing somehow, a little. Not the major numbers will be changing, but there will be a change in the answer. So don't be afraid that you have got some other answer, because you are showing the answer, you are showing your working, you are showing what values did you input. So the paper corrector can, if he or she wants to check, anyone can input these numbers into the calculator and they can check whether they are getting the same answer. This should be in dollars. So it is 560.8. 560.8, which is greater than dollar, what was Gemma's, this one, 54855. Therefore, we can say that Kaya had a higher salary. Therefore, Kaya had higher salary than Gemma in 2021. We are done with the subpart B. For this question number 3. Now we come to question number 4. Events, it contains 6 marks, no subparts. Events A and B are independent and P of A is equal to 3 times P of B. And given that P of A union B is equal to 0.68, find P of B. Because these two are independent events, therefore, since A and B are independent events, therefore, P of A intersection B will be equal to P of A times P of B. And they have given this relation P of A equal to 3 times P of B. Fine. Now we come to this. P of A union B is equal to P of A plus P of B minus P of A intersection. Okay. And in place of P of A union B, I am writing 0.68 equal to, we do not know what is P of A or P of B, has to be found out, but what we know is P of A is equal to 3 times P of B. So in place of P of A, I can write 3 P of B plus P of B minus P of A intersection B is P of A times P of B, and P of A is 3 P of B. So I can write this 3 P of B times P of B. And if you are getting confused by just dealing with P of B directly, then you just write let P of B be, say, X, because whatever is unknown is X. So let P of B be X. So this equation becomes, therefore, lines writing over here, 0.68 equal to 3x. 3x plus x is equal to 4x. So because 3 in place of P of B, I am writing x. So this is 3x and this is x. 3x plus x is 4x. And this is x, this is x. So it is minus 3x, which can be written as 3x squared minus 4x plus 0.68 equal to 0. Now again we have to calculator. This time it is the polynomial tool. So algebra, polynomial tool. P negative 4 and 0.8. Okay. Obviously, because it is a quadratic equation, you will be getting two answers. One is 0.2 and the other is 1.13. So let me write both of them. Therefore, x equal to 0.2 or x equal to 1.13. 1.13. But x is what? X is P of B. It is the probability. And probability cannot be more than 1. So we have to reject this. Okay. So therefore, P of B is equal to 0.2. So question number 5 is containing 6 marks. And it says a random sample of 9 adders were selected to see whether sleeping well affected their reaction times to a visual situation. Each adder's reaction time was measured twice. The first measurement for reaction time was taken on a morning after the adult had slept well. The second measurement was taken on a morning after the same adult had not slept well. The box and whisker plots, the box and whisker diagrams for the reaction times measured in seconds are shown below. Okay. This white one is the slept well thing, first reaction time, and this shaded one is not slept well. Fine, so let us come to the questions. Let us see what has been asked for. Consider the box and whisker diagram representing the reaction times after sleeping well. That means we have to take the white colored thing. So part A, state the median reaction time after well. Median reaction time after sleeping well. Median is this one. This is 0.24 and this is 0.30. There are two subdivisions in between. So this will be 0.26 and this will be 0.28 because the next one is 0.30. So it will be 0.28 seconds because you see, measured in seconds. Let me just write the median reaction time over here, 0.28 seconds. Okay, I'm not drawing the box. Let me just stick to the whatever I'm doing from the beginning. Let it stay like this. This is the answer for the subpart A. The median is 0.28 seconds. Subpart B, verify that the measurement of 0.46 seconds is not an outlier for this sleeping well part. That is this white box and whisker. 0.46 seconds is not an outlier. For that, first of all, we have to get the IQR interquartile range. What is this one? This is 0.26 and this one is 0.28. This one will be 0.2 and what is this one? Obviously, this is 0.3. So lower quartile is 0.27, upper quartile is 0.25. Let us first. The part B. Yeah. Lower quartile to 1 equal to 0.27 seconds. 0.2. Upper quartile Q equal to 0.35. 0.56. So IQR quartile range will be 0.35 minus 0.2. 0.35 minus 7. Enter 0.08. And in order to be an outlier, first of all, let us find what is Q3. I'm taking Q3 because you see Q3 is 0.5 and the value that has been given to us is 0.46, which is more than 0.35. That is why we understand that it will be on the right side. If it had been, say, 0.10 seconds, then we would have taken Q1 because we would have tested whether it is the outlier on the left-hand side, whether it is smaller than the smallest admissible data. But for this is on the right side. We have to check whether 0.46 is greater than the highest admissible data, which will not be an outlier. So that is why I am taking Q3 plus 1.5 times IQ. This is equal to 0.5 plus 1.5 times 0.0. Let us find value of this. 0.35 plus 1.5 times 0.08. It is 0.47. This is the highest value which will not be considered as an outlier. You have 0.48, that will be an outlier. Since .46 seconds is less than 0.47 seconds, therefore, .46 seconds is not an outlier. We are done with, we have proved that 0.46 seconds is not an outlier. Now coming to subpart C. State why it appears that the mean reaction is greater than the median reaction. The box and whisker plot say nothing about the mean value of the data. But even then they are saying why it appears, means we can expect or we it appears it is what we feel like, that maybe mean value will be more than the median value. We are not sure because the box and whisker plot will never be giving the mean value. You cannot find the mean value by looking at a box and whisker diagram. But is this because this is the well box and whisker diagram? Is this symmetrical? Is this box and whisker plot symmetrical? Definitely not, because the right whisker is longer than the left whisker. Therefore, it is positively skewed. The distribution is positively skewed. It is not symmetric. And for positive skewed distribution, you have, let me just draw the, this is part C. I'm not giving the names for the axis. I don't know. Over here, and it will be seconds, and it will be different from data to data. So there are two axes. And if it is a symmetrical distribution, right? Fairly symmetrical distribution, definitely not accurate, but I my intention is to draw the asymmetrical distribution. And for a symmetrical distribution, this point will be this is symmetrical. Oh, probably you are not being symmetrical. For a symmetrical distribution, this is mean equal to median equal to mode. Mode is the highest value, which is this. For a symmetrical distribution. Okay? For a positively skewed distribution, it is a positively skewed distribution. This is the highest point. This is positively skewed. This is the mode. Since more number of data is on this side, therefore the mean, it will be the median, the average. So it will be maybe somewhere over here. This will be the mean. And the median is the middle point. So this will be the median. This will be the median. And for the negatively skewed thing, negatively skewed distribution. This is the mode. This is negatively skewed. This is the mode. And because there are more number of data on the left side, therefore the mean can be here. Is the average. And median is always the middle. It may this is me. Therefore, the question is saying that why it appears that the mean reaction time is greater than the median reaction time. Because it is positively skewed, the distribution is positively skewed. We are having a long right whisker. The right whisker is longer than the the left whisker. That suggests that it is a positively skewed distribution. And for a positively skewed distribution, you see the mean is, this value is obviously more than this value. Okay? So you can write the answer as, since the right whisker of the box plot is longer than the left whisker, the distribution is positively skewed. Therefore, the mean reaction time appears to be more than the median reaction time. Now it is the part D. Now consider the two box and whisker diagrams. comment, DS comment on whether these box and whisker diagrams provide any evidence that might suggest that not sleeping well causes an increasing, not sleeping well causes an increase in reaction time. Let me just go back very first statement question. A random sample of 9 adders. Just by taking 9 adders, if you have done your IA related to some statistics, you have collected some data, you should be knowing that taking only 9 data is not enough to come to a conclusion. So over here, only 9 adults have been selected. The sample size is just 9. And even if we see that when they are not sleeping well, when they are not sleeping enough, the reaction time of these 9 adults are in. We cannot say conclusively, cannot give 100% guarantee assurance that it will happen for every individual. Some individuals, they can just cope up with every type of severe or many severe circumstances. Even when they cannot sleep, they sleep for at least 1 or 2 hours, maybe, or they cannot sleep even for a single hour one night. That doesn't affect their performance on the next day. They can manage. So just by taking the sample size of 9 adders, we cannot say anything correct. It's in a concrete way that yeah, it's conclusive way that this should happen, this will happen. We cannot say anything that's out. Cannot come to any conclusion. So now let us look at the box and whisker of these. We are seeing obviously when the adults are not sleeping well, because this should be the general thing, normal. If you don't sleep well, you don't feel well, and your mood may also fluctuate, and cannot work properly, you may concentrate properly. These are the normal manifestations of not sleeping, not having a good night's sleep. So that is what has been here. We are seeing that when the adults are not sleeping well, this is the median. This is the median, which is 0.35 seconds. That means 50% of the adults' reaction time is below 0.35 seconds when they are not having a night's sleep. But whereas 75, because this is Q3, 75% of the adults' reaction time is below 0.35 seconds. Okay? But and also the maximum reaction time for the adults, those 9 adults who have slept well, is 0.46. This one is 0.48. It is not so very pronounced, this difference, but of course this one is 50% and this one is 75%. It's much more pronounced. So we can say that. Of course, by looking at these box plots, we can say that we can deduce or infer that those the reaction time increases when the adult is not sleeping well properly, but the sample size of 9 adults is too small to say anything conclusive. is right. RC that the median of not sleep well in value in time is equal to, I'm putting equal to because I don't have much sleep. The upper quartile time of keeping well of slots this suggests that the reaction time does in and not sleep. But a sample size of 9 is too small to say anything conclusively. But definitely. See that the median time of not sleep well is time of. This suggests that is the reaction time does increase when you do not sleep well, but a sample size of 9 is too small to say anything. Question number maximum mark 7. A particle moves in a straight line such that its velocity 3 meter per second at time t seconds is given by this equation. T is between 0 to 3, both included. The part A says determine when the particle changes its direction of motion. When the particle will be changing its direction of motion, the instantaneous velocity will be, or the velocity of the particle will be instantaneously zero. It will be at rest. Okay. So plain and simple, we have to equate this to 0. How can we equate this to 0? We can graph this and we will be finding the zeros. Okay. So x squared, let us get the graph first of all. Okay. X squared plus 1 squared plus 1 times cos x over 4 over 4. And we have to take the time between 0 to, let me, between -1 to 4, because otherwise the axis, y-axis and the x-axis, they will not. Actually, not interested. Find the times when particles accelerate. Okay, first of all, let us do. Okay, fine. So what is the? There's only a single zero. We will be analyzing the graph. 1.57. 1.57. It is actually pi is 0.1 dot divided by 2 will be 1.57, but you don't have to remember that. You have to write pi by 2. It is 1. So it is equal to 1.57. And then subpart B says find the times, so multiple, more than one. This you have to read the question carefully. This is suggesting that you will be having more than one answer. Okay? When the particle's acceleration is negative 1.9 meter per second. So let us get the acceleration graph first of all. I can get the acceleration graph. For that, I have to draw another. And it will be x x. This one is x2, f2. So I'll be taking, because get the velocity, we get acceleration. So f2. This. Stay over. Let us stay over there. They're asking negative 1.9 meter per second square. That means I have to draw a line, y goes negative 9. So I have to negative 1. See, you are having two intersections. Over here, this one and this one. Therefore, you see time, so you are having two intersections. Now we will be taking the analyzed graph thing and intersection. These two, this one and this one. another analyzed graph, intersection graph, this graph, this graph. This one is 2.26 and this one is 2.96. You see, because we have to take the x values. These are the times, 2.26 seconds and 2.96 seconds. T equal to 0.2 second and T equal to 0.96 seconds. So part C says, find the particle's acceleration when its speed is at its speed. Speed is what? Absolute value of the velocity function. So when is the speed greatest? Let us draw another graph. Okay? The only thing that we have to remember is the velocity function is this F2. Otherwise, we have to write it once more. We can write it, but I am avoiding that. I'll be remembering this velocity function is F2. Okay? So I take another graph sheet and this will be the speed. Therefore, it is this one. This is the speed. Now they are saying, and it is between 0 to 3. I have to take, let me take from -1 to +4 as I had taken before. 1 to 4. Will can take this in, can take this to anyway. And they are asking what is the acceleration, particles acceleration when speed is the greatest. What I can do is, first of all, let me find where is the speed greatest. Guys, graph maximum. This is 3.6, it is over 3. Cannot take this. I have to take, let me change the graph set. I have to take this as 3. Take 3. Then, okay. So over here, you see, this is just increase. If I just, I again says graph settings to 4. You see, up to 3.62, it is increasing because 3.62 at 3.62 it is the maximum. It is increasing at 3 also. If I take x equal to 3 time, I can draw that. of it 9. This is the x equal to 3 line. And if I take the dice graph and get them, this section is 3 and 2.47. So it is just rising. So up to 3 I can take. So I'll be taking at at t equal to 3, we are having the maximum speed, because from 0 to 3, this is the maximum value of the speed in time 0 to 3 seconds. Okay. So I have just got the time where the speed is maximum. Next, I can go to this graph. And I have to get this black colored one is, you see, the acceleration. So I have to get t equal to 3 seconds. So I will be drawing the t equal to 3 seconds line, vertical line. This template and line, and this is the t equal to x equal to means t equal to 3. And we have to get the acceleration when t equal to 3. So it is anti analyze graph into graph, this graph, and this graph. This corner. It is negative 1.84. You see, t or x equal to 3 and negative 1.84. This is at equal to 3 seconds. Speed is maximum. Acceleration equal to negative 1.84. This one, negative 1.84. Negative 1.84 meter per second square. And the particle's acceleration when its speed is at its greatest. The speed is greatest when t seconds, and corresponding acceleration is negative 1.4 meter per second. So students, this brings us to the end of this session, because we have completed all the 6 questions. And as I've said before, we will be solving the section B questions of the same paper. That means questions 9 will be solved tomorrow. Will be starting at 5 p.m. IST. And again, I am repeating, if any one of you is interested in knowing how to solve the paper 1 and paper 2 questions of IB Math AA SL November 2022, then please do send to me the PDF format of those 2 question papers, my mailbox, and I'll be explaining how to answer questions in one of these coming weekend. And yeah, because we are having live sessions, and so we'll be solving on it. And there is no more time remaining, as there are only 2 more weeks remaining, and you are having your I am just assuming that you are having your examination on May 8 and May 9, because you have the different time zone. I am assuming that you are having days. Okay. So thank you for staying with me till the end. I hope you have understood how to solve these questions. If you have any query, please feel free to write to me in the comment. I'll be trying to answer you as far as possible. Okay? We meet again then. Actually, I don't know because I'm not having any question paper. Anyway, all the best for your coming examination. Bye.